Alright, hey guys, this one is going to be a pretty quick one. I just spent a bunch of time doing the page 134 homework. That was a really long one, but 129 is going to be pretty easy, so here goes. This first bit is really just kind of trying to get you to take notes again, really, so it's technically homework, but we're really just kind of forcing you to study and to think about the relationships again. So up here it's asking you to find the sine of A and the sine of B. And again, if you are referencing off of A and we want sine, well, the opposite side is A. And the hypotenuse is always across from the right angle, so that would be C. So the sine of A is just the fraction A over C. You're not giving me numerical answers here. You're just giving me fractions with letters in them, and that's it. Now if you want the sine of B though, well, B is down here, and the side that's opposite from angle B is side B. So my numerator would now be B. My denominator, my hypotenuse, that would actually still be C. But so we end up with a sine of A that's A over C and a sine of B that's B over C. And that's it. Now for cosine of A, if I come back to A, then we want the adjacent side now, and that's B. So our cosine of A would be the B over C. And the cosine of B, well, if I'm referencing off of B, then B, it's A that's adjacent. And the hypotenuse is still C. So there's the two cosine fractions. Then for tangent, what do we got? For tangent of A, opposite over adjacent would be A over B. But for the tangent of B, if I'm looking at B, then opposite is B and adjacent is A. So the tangent here would be the reciprocal, B over A. That's all for that. Then down here they want you just to fill in SOHCAHTOA one more time, just to remember what all this stands for. Whoops. So it's SOHCAHTOA. And again, it's meant to help you remember which sides to use. So they're saying here, sine, well, the numerator must be the O, which is opposite. The denominator is H, which is hypotenuse. And then similarly for cosine, the numerator is adjacent. The denominator is hypotenuse. For tangent, the numerator is opposite, and the denominator is adjacent. And you really, really, really have to study that and know that so that you can do well tomorrow. Next. All right, so now for a problem like this, you're just writing a bunch of fractions. And so for this problem, you have all three side lengths. So this time, instead of giving me a fraction that just has variables in it, you can give me fractions that have the actual number values. So what would be the sine of A? Well, if I'm looking here at A, then opposite is 5 and hypotenuse is 13. So this fraction would be 5 over 13. That's it. Just write the fraction. Don't make it a decimal. Don't do anything else. That's it. Now if you want the cosine of A, then adjacent is 12 and the hypotenuse is still 13. So you'd give 12 over 13. And if you want the tangent of A, then you'll go 5 over 12. That's it. Then if we switch gears and now look at angle C down here in red, then sine, the opposite is now 12. So you end up getting 12 over 13, which, as I mentioned in the last video, that's going to happen every single time that the old cosine becomes the new sine. And it's going to happen again, that the old sine becomes our new cosine. Now let's double check and make sure. But our cosine would be adjacent over hypotenuse. That would be 5 over 13, which is what our old sine was. So this isn't like some trick that just works sometimes. This always happens, that the sine of A is the same as the cosine of C. And the cosine of A is the same as the sine of C. And we said there was another rule for tangent too, which is that you just do the reciprocal. And so instead of 5 over 12, you get 12 over 5. But those are your three ratios for all three angles, or for both angles. So we end up with a total of 6 things. All right, on the next one, we have to work a little bit harder this time because we don't have all three sides. I don't like the look of this. Let me clean this up. Okay, so I made it bigger, that's all. Now, looking here, if I was using W, then opposite would be 12 and adjacent would be 9. So even if I didn't know this side here, the hypotenuse, I could still say that the tangent of W, opposite over adjacent, is 12 over 9. But remember, 12 over 9 is a fraction that reduces. They're both divisible by 3. So dividing by 3 gives 4, and dividing by 3 gives 3. So you actually have to give me the answer 4/3. And that means that the tangent of x would be 3/4. But I can't get sine or cosine until I know the hypotenuse. So like it or not, we're going to have to get in here and solve for this side here, which is going to be called x. So just do Pythagorean theorem. It'll be 9 squared plus 12 squared. You'll set that equal to x squared. So you're going to get an 81 and a 144 by squaring those numbers, which adds up to 225. And you take the square root of both sides. And the square root of 225 happens to be exactly 15. So that means that this hypotenuse is exactly 15, which would mean that the sine of W, if I do opposite over hypotenuse, is 12 over 15. But wait, 12 over 15 reduces because they're divisible by 3. So if you divide by 3, you get 4/5. So sine of W should be 4/5. And the cosine of W, well, cosine of W would use adjacent over hypotenuse. It would be 9/15. But those numbers are again divisible by 3. So this time you get 3/5. But there's all three trig functions for W. That means for X, can I just use the trick where I flip-flop these guys? I think I can. So cosine as 3/5 is going to become sine as 3/5. And sine at 4/5 will become our cosine at 4/5. And of course, we already said that the tangent of X will be the reciprocal of the tangent of W. So you'll end up with 3/4 instead of 4/3. But that's it. And then number 3 is the last one. And it's the same as the one before. We just have to do some math to figure out our missing side. Let me clean this up again. All right, let me grab just that. And let me grab just this triangle. Throw the rest in the trash. All right, so probably our first step is to solve for that missing side, since we know that we need all three to do these trig ratios. So if I were you, I would call that missing side x. And plugging into the Pythagorean theorem, you would have a squared plus b squared equals c squared. And just never forget, never ever forget, that the hypotenuse has to get plugged in for c. So you're doing a 34 squared. Then you're taking the x and the 16 and plugging them in for a and b. So you have an x squared plus a 16 squared. And I happen to know that 16 squared is 256. And I happen to not know what the heck 34 squared is. So I'll use my calculator. 34 squared means 34 times 34, which is 1156. Okay, so to get x alone, we'll subtract 256 from both sides. And we'll see what that comes out to, because I don't know. But if we do 1156 minus 256, then it's 900, which I should have known that that was 900. But now we take the square root of both sides. If I take the square root of x squared, it turns into plain old x. If I take the square root of 900, this is another one that actually comes out cleanly. It's exactly 30. So we can use 30 as the side over here. And then all of our trig values should be easy. You just give me a bunch of fractions. So for the sine of L, you're focusing on L. And the opposite side would be the 30 we just found, divided by the 34. And reducing that fraction should be pretty easy because they're just both even, so chop them both in half, and you'll get 15 over 17. And then you can't go any farther because 17 is prime. It doesn't have any other numbers that it's divisible by. So what about cosine of L? Cosine of L would use 16 as the adjacent over 34. And if you've got 16 over 34 and you chop them both in half, you get 8 over 17. And the tangent of L is opposite over adjacent, 30 over 16. That's going to be, when you reduce it, 15 over 8. So there's the three trig values for L. And one more time, we can kind of take a shortcut here and just say sine's going to become cosine, 15 over 17. Cosine's going to become sine, 8 over 17. And tangent is going to become the reciprocal. It's going to go to 8 over 15. And then that's it for this whole assignment. What did that take? That took 11 minutes and 15 seconds. So that's page 129 done. See ya tomorrow.